on, my tablet's not working again, as usual. Um, Here we are. Oopsie daisy. Come on, don't delete anything. Okay, all the people you should give credit to is here. Yes, and now let's go back to the, how do we go back? Oh, come on, come on. No, 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 please don't delete this. Oh, okay. I need you to move. There we go. Yeah, there we go. That's the easiest move I ever had. Okay, that's nice. All right. For the follow, so last time we were here, and let me just erase this over here. But I just realized something. There's a few things I didn't talk about, like the continuity and the power of the electronic force of certain things. Yeah, I didn't talk about that at all. So, and I know that Dr. Centillion talked about this first, so I should have done this first, honestly. Um, so my mistake. Let me bring this up really quickly. So there is an airfoil like this, and then if you look at the little tiny, oh, I delete the backset. Okay. Uh, there we go. If you look at the tiny little skimmit of this, like this portion over here, you'll see a graph like this that shows you this density thing. We're assuming this is a hypothesis, and we're assuming this portion over here. Every time we think of the equations, we're thinking of that position. So that's something you should know. So basically, what's saying is a continuum. I think it's called a continuum hypothesis. Basically, if I remember correctly, how you're supposed to write it is that when L over here, some length scale, is greater than the dimensions of all the dots like this, is the key. So then you can say density x comma t equal the limit of summation of mi divided by v delta. And then delta v goes to, that I'll just call myself lazy to make myself feel better that I forgot about it. When I say lazy, it just means I forgot half the time. Uh, okay, so is d density dt over here divided by order of gradient dot density v bar. Okay, we got that. So this is our comparison. What comparison does this give? Well, this is the continuity comparison, I believe, uh, which is which is basically the t plus a gradient dot density v bar equals 0. So that comparison is done here, and I'm assuming this length scale is now cancel t is on the bottom, v divided by that, and then m goes away. I'm missing something. I'm missing L. Length scale, length scale. How do I get length scale from here? Time length scale bottom up here, length scale. So it's really L divided by V time. So, ching, that's the first one. Of I don't remember, but I think, well, it has to be the acceleration term first because that term is quite essentially what we're ordering. And then that in turn, I mean, we could get rid of the density because the other side has density, right? So we'll just do V divided by dt. I think that's what he did. I don't remember if he did that. But I think he's doing the convective term because yeah, I think so. I think this is all one of the other side of this side of the equation, um, which is fair. Now V cancels out with V, and then it's not really, it's U infinity and so on, but good enough for me. A relative V, like no, that's not right. It's an L over here, and then T on the bottom. I think there's a V. Okay, good. For the energy, it's gonna be a little confusing. I believe it's gonna be the ds dt, this one. So it's gonna be ds dt divided by order of v dot s. So the s cancels out, which leaves you with v on the bottom. Then this gives you a length scale. And then there's t over here, pitching. Okay, we have done it. Done all of them. And now, what does he want? What these? These are characteristic lengths, like these are just characteristics. Okay. I see, I see. He did the same idea for this one. So he did the order analysis and got this idea, and because this idea, so on and so forth. He's trying to argue the other ones are negligible too. Now, I think I might be wrong, but I think that's what he's saying. Another term, this term over here. Um, so beautifully enough, with that said, we can get a simplified version, I'm assuming. Okay. Around the body, okay. Sphere radius r, where else the values vc and tc will be characterized the free stream velocities, and the characterized time of free stream variation igt equal. I can't say that. If this is really small, this portion doesn't matter. So what that means makes sense, yeah. Yeah, okay. So that's how they get it. Now, and then over here, we got rid of the acceleration term, so the convective term where the density must stay, right? Yes. And then the last term, we only have the weird convection term with the s. So beta delta s equals 0. And the density still stays, I believe. I'm not sure if it's because convective. Oh, wait, density doesn't stay, right? It doesn't stay because it can be divided by density. So we can just density. So that gives you be that this. So beautiful. Okay, we got that. Replace whatever brain cells I have with knowledge. All right. So first off, Fm equals negative gradient u. Surprisingly, he doesn't use a bar anymore. Okay, maybe, no, he does use a bar. I think. Never mind. I'm just a fool again. Anyways, I don't know why that's important, but we also have the famous convective term, and this equals negative p divided by density minus u. That is okay. That's okay. That is okay. Now, there's another form of this, but I usually don't remember it, so um, I'm gonna have to prove it. So let's prove it. He just brings this up. I don't remember how to do. You know what? We're going to index notation again because I'm a fool. Okay, don't question me. I don't remember. So apparently this minus this uh, uh equals the other stuff. So let's just figure this out. So this is a cross product, but if you didn't know. So let's do um xi v dot v. So that's just the erase thing over there. vk divided by 2 minus v. Oh, okay. So I have to use epsilon ijk vj, and then you're going to do epsilon. Uh, is there any connection between these two? There has to be. So it's k, and let's just say this is m, and then we just need. Oh wait, this is wrong. So I did a long time since I did this form. Epsilon. Oh, I'm a fool. Oh, come on, tablet. You need to write better, brain. Epsilon MLK there. And then this will be, where is it? Okay, here's this. So then it's going to be VL. And I think I did this format wrong. So this is going to be Civita, I think. Beautiful, hopefully. And it is. Okay, IL delta JM minus delta IM delta I JL. We did this in our midterm, which is quite interesting. Okay. Yeah, that we didn't get this right. Because I'm a fool. Excuse my abhorrent notations because this is quite literally the worst notations I have ever given someone. Um, yeah, I've never been more embarrassed by my notations. Um, okay. Yeah, excuse my notation work. It is awful. It's because it's not because it's my fault. I usually type this, so I just copy and paste the same identity like 20 times. That's why it makes it easy. But my notations right now is complete garbage. So and then we got scolded on it. No, this is a dot. This is dot product. No, this is a product rule. Product rule. Product rule. Yes, 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 yes. Product rule will save our shit. So let's leave out the 1/2. We know the product rule says that we have delta. What I'm saying is in a midterm, I think we all, a lot of people got this a lot, including me. I think I got this wrong. So maybe I didn't. I don't remember. VK this VK plus VK um, delta delta xi VK, which equals two of these. So this is delta xi VK VK. Now that shows you that that is equivalent to saying in this version here that this cancels out with that, leaving us with equal to VI delta XI VI, which is VJ, I think, which is equivalent to say V dot gradient V. Yeah, that was hard. I forgot